Alright, so right now we're going to be working free response number 1 from 2012. And the problem reads, let R be the region in the first quadrant bounded by the x-axis and the graphs of y equals ln x and y equals 5 minus x as shown in the figure above. And this is a figure. And so to find out which line is which, we go to our calculators, hit y equals, and we plug in the equations, hit graph, and these are the graphs, the lines that we are given. So we go back to the figure and we label it. This line right here is y equals ln x, and this one is y equals 5 minus x, and they intersect at point AB, as I've decided to call it. And so let's move to part A. Part A asks us to find the area of R, and so to do that we're going to use the equation A, the integral of A to B, top minus bottom dx. And so if we go back to the figure, as we can see, we have a bit of a problem right here because the graph splits. So from 1 to A, point A, the top equation is y equals ln x and the bottom is 0. But then from A to x equals 5, the top equation is y equals 5 minus x and the bottom is 0. So what we're going to have to do is we're going to have to find the area of each piece and then add them together. So to do that, first we have to find out what A and B are. So we go back to our calculator and we hit second trace 5 for intersect, and we're going to hit enter 3 times. And we are given our intersection, which in this case A equals 3.6934414 and B is 1.3065586. With that knowledge, we go back to our equation and we just plug in basically. So for this part right here, this piece, our top equation is going to be ln of x. So we're going to go from 1 to 3.6934414. Again, top in this case is ln x minus bottom, which is 0, dx, plus the integral of 3.6934414 to 5, because that's where the figure is bounded. The top in this case is 5 minus x and the bottom is still 0, dx. So we're going to go back to our calculators. We're going to hit math 9 and we're given the integral sign, so we're going to go from 1 to 3.6934414, and to make things easier we're just going to hit vars, y vars 1 and 1 because the first equation is written in y1, minus 0 dx, plus again math 9, and this time we're going to do 3.6934414 to 5. Again, vars, y vars function, and this time we're going to hit 2 because 5 minus x is plugged in into y minus y2 minus 0 dx, and we're going to hit enter. And we are given the answer 2.985804105. But for these purposes, we're going to have to cut down to the first 3 decimal points, so the answer ends up being 2.986. And that is the area of R.